Welcome back to Biology with Mrs. Evans. We have finished our unit on science in general and are moving into Unit 2, which is all about biochemistry. Biochemistry is all of the chemical processes that go on in an organism. Therefore, in this unit, we will learn about the different types of bonds, macromolecules, and amazing properties of water, etc. In this video in particular, we will review information you learned in elementary school and middle school and build upon it. When you hear the word chemistry, you probably think of an atom, which you should already be familiar with, so this will be a quick review of an atom. An atom is the basic unit of matter. In chemistry, you will learn about the history of the atom and you will go into a lot more detail, but for this class, you just simply need to know that an atom consists of 3 subatomic particles. The first of these is the neutron. Neutron, easy way to remember that if you underline this first 3 letters. Neutrons are neutral. They do not have a charge. They are located in the nucleus of an atom. Protons are positively charged, and they are also located in the nucleus of an atom. And in a way to remember protons is just remember P for positive. Neutrons and protons make up the majority of the mass of an atom. Electrons are much smaller. They are only about 1/1800th of their size, and they are negatively charged. They are not located in the nucleus of the atom. They are free to orbit around the nucleus of an atom, and I'm going to go into more detail on that in a second. All right, so this is a good model for the atom. Again, you'll notice that the protons and neutrons are in the nucleus of the atom, and this model shows you that the electrons are free to orbit around the nucleus. We do not know where an electron is in any given moment, so this particular model is what we call the electron cloud model, which means is that the electrons are in the electron cloud orbiting the nucleus of an atom. The second thing that pops into your mind probably when you hear the word chemistry is the periodic table. The periodic table is a picture representation of all of the elements that we know exist in nature, some that we've created ourselves, and some that we believe exist in nature and we haven't just discovered them yet. So in chemistry class, you'll go into a lot more detail about the different parts of information that the periodic table gives you, like how it's arranged and things like that. But for this class, there's only a few things that you need to know about the periodic table. The first is the group number. In the old versions of periodic tables, the group number was simply a Roman numeral. So you see here Roman numeral 1, Roman numeral 2. In the newer versions, you'll see a number. This one has both. You see group 1, group 2. And what the group number tells you is the number of electrons that are in the outermost shell of that particular element. And these electrons are special because they are the reason why elements react the way that they do. And these electrons are called valence electrons. And I'm going to talk a little bit more about those in a moment. You'll notice also that each element has a symbol that represents that element. It can be either 1 letter or it can be 2 letters. So carbon, we're going to focus a lot on carbon, and I'm going to switch to the next slide so we can go into a little bit more detail on that slide. All right, so here's carbon basically blown up so it's easier to see. So the first thing is the atomic number. You learned the atomic number in elementary school and again in middle school, and the definition, if you look it up, tells you that the atomic number tells you the number of protons in an element. In reality, it also tells you the number of electrons, and the reason why is because an element of itself is neutral, which means it has equal number of protons and electrons. So for me, when I ask you what the atomic number is, I need you to know that it is the number of protons and the number of electrons, and that is this number right here. So this 6 tells me that carbon has 6 electrons and 6 protons. And again, you'll notice the symbol for carbon is the capital C there. The number that you see down here, and I apologize that it got cut off because it got messed up in the transfer, this should be 12.011, and that number is the atomic mass. The atomic mass is not a whole number as you see. It is basically the average of all of the isotopes of carbon. I'm going to go into the isotopes of carbon in a minute. But the atomic mass, if you take the atomic number and you subtract it from the atomic mass, it tells you the number of neutrons. So for carbon, I take 12, subtract 6, which is the atomic number, and I can calculate that carbon has 6 neutrons. All right, so I talked about isotopes just a second ago because the atomic mass, as you noticed, is basically not a whole number. It shows an average of an isotope. So what exactly is an isotope? An isotope is atoms of the same element, but they differ in the number of neutrons. The change in the number of neutrons can change the properties of that element. And on the screen, you notice that I have carbon 13, carbon 14, and the normal one, which is carbon 12. And we name isotopes based on their mass number. So carbon 13 tells me that it gained 1 neutron. Carbon 14 tells me that it gained 2 neutrons because the norm for carbon is carbon 12, which has 6. So let's take a look at the picture representation that I have here for the 3 different types of carbon. The normal type of carbon is 6 electrons, 6 protons, 6 neutrons. So you see the 6 electrons here orbiting the nucleus of the atom, and then inside the nucleus you see the 6 protons and 6 neutrons. Carbon 13, you'll notice that there is 1 additional neutron in the center, but it still maintains 6 electrons and 6 protons. And then carbon 14, if you notice, it has 2 additional neutrons, still maintains 6 electrons and 6 protons. And you also notice that carbon 12 and carbon 13 are both non-radioactive. But as soon as you add that second neutron, carbon 14 becomes radioactive. And you learned a lot about carbon 14 in earth science and how we use that to date fossils. So far in this video, we've been focusing on simple elements. A compound is a chemical combination of 2 or more elements that are the same or different. So water, H2O, that is a compound. The air that we breathe, which is O2, is a compound. Still the same element, but there are 2 of them combined together. Chemical formulas are basically an alphanumeric shorthand that scientists use to show the elements in a compound. It's much easier to write H2O than it is to write hydrogen to oxygen 1. So it's a shorthand that we use, and it tells us the atoms that are in the compound or molecule and also the number of each of those atoms. So H2O tells us there are 2 hydrogen atoms and 1 oxygen atom bonded together. Again, the air that we breathe, that is simply O2, and there are 2 oxygen atoms bonded together. And the one that you see down here at the bottom, you'll want to make note of it, is because you're going to need to know it, and that is glucose, C6H12O6. And again, basically with the transfer over, these should be subscripts, so these should be a little 2 that you should be familiar with when you look at chemical equations. So C6H12O6 is glucose. You need to know that, and we're going to go into a lot of detail when we get into cellular energy and photosynthesis, because you should know that that is the end result or the product of photosynthesis. All right, so the last thing that we're going to talk about in this video is the octet rule. When I talked about the group number on the periodic table, the group number, remember, tells you the number of valence electrons in a specific element. And I pointed out group 1 has 1 valence electron, group 2 would have 2 valence electrons. And these electrons are what are responsible for how these elements are going to react. These are the electrons that are available to form bonds, so you do need to know what they are. So valence electrons in the outermost shell that are responsible for how an element forms bonds. And the octet rule simply means is that atoms want to be stable. And in order to achieve this stability, they have to fill this outer shell. And when you get into chemistry, you'll talk about electron configuration, and you'll go all about the ins and outs of that. But for this class, you just need to know that there are different levels. And for the first level of electrons, it only requires 2 electrons to be full, and then the second level requires 8. That's why it's called Octet. If you take German, Acht means 8. All right, so 2 electrons in the first level, 8 electrons in the second level, in order to basically become stable. In middle school, you learned about the noble gases. Those are the ones that are in group 8. All right, they already have 8 electrons in their outer shell, so they are full and they do not want to react with anyone. But for everybody else, if they don't have 8 in their outer shell, or 2 with the exception of hydrogen and helium, then they need to react. So we're going to talk about bonds and things like that in later videos. But for this, just know octet rule. Elements want to be stable, so they need to fill their outer shell, whether it's 2 in the case of the first 2 electrons, and the example of that would be hydrogen and helium, and then 8 for all of the other elements. They want 8 in that outer shell.